Good day, Doctor. My name is CHUAH. Today, I will be presenting on a PPG-based pulse oximeter system using MOSFET. In this presentation, I will explain what a pulse oximeter is and how PPG technology works, and most importantly, how a MOSFET is used within the system to control the LEDs used for blood oxygen measurement. A pulse oximeter is a non-invasive biomedical device used to measure blood oxygen saturation, also known as SpO2 and heart rate. It is commonly used in hospitals, clinics, emergency departments, and home healthcare. The device works by shining light through a finger and analyzing how much light is absorbed by the blood. This allows healthcare professionals to quickly assess whether a patient is receiving enough blood. PPG stands for photoplethysmography. It is an optical sensing technique used to detect changes in blood volume inside blood vessels. A PPG system consists of three main components, which are a light source, usually an LED, and also a photodetector, such as a photodiode, and a signal processing circuit. As the heart pumps blood, the blood volume changes continuously. This is absorbed by the tissue and producing a PPG signal. This slide shows a typical PPG waveform. The peaks occur when blood volume increases during a heartbeat, which is known as systole. The valleys occurs when blood volume decreases between heartbeats, known as diastole. The time interval between two peaks can be used to calculate heart rate. The waveform amplitude also provides information about blood circulation and vascular health. A pulse oximeter uses two LEDs with different wavelengths. The first is a red LED operating at approximately 660 nanometers. The second is an infrared LED operating at approximately 940 nanometers. Oxygenated blood and deoxygenated hemoglobin absorb this wavelength differently. A photodiode measures the amount of light that passes through the finger. The device then analyzes the differences in light absorption to calculate blood oxygen saturation. This diagram illustrates how oxygenated and deoxygenated blood interact with light. Oxygenated blood absorbs more infrared light and allows more red light to pass through. On the other hand, deoxygenated blood absorbs more red light. By comparing the signals from the red and infrared LEDs, the pulse oximeter can estimate. This block diagram shows the overall operation of the pulse oximeter. First, the red and infrared LEDs emit light into the finger tissue. Then, the photodiode detects the transmitted light. The signal is then amplified and filtered to remove noise. Next, a microcontroller processes the signal and calculates the SpO2 value and heart rate. Finally, the results are displayed to the user. MOSFET stands for metal oxide semiconductor field effect transistor. It has three terminals, which are gate, drain, and source. A MOSFET is a voltage control device, meaning a small voltage applied to the gate can control a larger current flowing through the device. MOSFETs are widely used because they offer fast switching speed, low power consumption, and high efficiency. These characteristics make them suitable for biomedical electronics. This is the main circuit discussed in this presentation. In this circuit, the GPIO pin from the microcontroller controls the gate of the IRL 540N MOSFET. The MOSFET acts as an electronic switch. When the gate receives a high signal, the MOSFET turns on and allows current to flow through the LED. As a result, the LED emits light. When the gate signal becomes low, the MOSFET turns off and the LED stops emitting lights. Resistor R1 protects the GPIO pin, R2 acts as a pull-down resistor, and R3 limits the current through the LED. In a pulse oximeter, this switching mechanism is used. The MOSFET operates by controlling current flow between the drain and the source terminals. When a gate voltage is applied, the MOSFET turns on and current flows through the LED. The LED then emits light into the finger tissue. When the gate voltage is removed, the MOSFET turns off and current flow stops. The advantages of this approach include fast response time, accurate LED control, and reduced power consumption. MOSFET provides several important advantages in biomedical devices. They consume very little power, which helps extend battery life. They offer high switching speed, allowing precise control of sensors and LEDs. They are also compact, reliable, and highly efficient. These characteristics make MOSFETs ideal for portable and wearable healthcare devices. Now, the PPG technology is widely used in many healthcare applications. Examples include fingertip pulse oximeters, hospital monitoring systems, intensive care units, fitness trackers, and also smartwatch. Modern wearable devices such as the Apple Watch and Fitbit also use PPG technology to monitor heart rate and blood oxygen levels. The future of pulse oximetry includes wireless monitoring and Internet of Things (IoT) healthcare systems. Wearable devices are becoming more advanced and can continuously monitor patients remotely. Artificial intelligence is also being integrated into healthcare systems today to improve diagnosis and patient monitoring. MOSFET technology will continue supporting these developments through low-power electronic designs. In conclusion, pulse oximeters use PPG technology to measure oxygen saturation and heart rate. The system relies on red and infrared LEDs together with a photodiode to acquire optical signals from the body. MOSFETs play an important role by acting as electronic switches that control LED operations. Their fast switching speed, high efficiency, and low power consumption make them ideal for portable biomedical devices. Therefore, MOSFETs are an essential component in modern PPG-based pulse oximeter system. That's all from me. Thank you for listening.